Friends, and in this video we are going to solve some more examples of the maxima and minima, how to find the local maxima and the local minima. And you know that local maxima and local minima are just nothing but they are simply, we also call them as the maxima or minima. Now here I take one example of fx equals sin x. So fx equals sin x. So the step one, first we have to find the differentiation of this one. So we have to find f dash x equal to cos x. So differentiation of fx is cos x. Now you have to solve this equation by making f dash x equals 0. Therefore cos x equal to 0. Now we know that those who have studied the trigonometrical equations, that cos x is 0 means x equal to odd multiple of pi by 2. So this is pi by 2. And now if I plot the function of cos x, or better I say sin x, because we have to find the maximum and minimum of sin x. So if I plot this graph, so it goes like this. Before 0 I am not plotting, you can take it before 0 also. This is 0, this maximum value is at pi by 2, this is pi, this is 3 pi by 2. If you forget the maxima and minima, and then if you see the peak value of this graph, which is here 1, so at pi by 2 this is the maximum value, so this is a local maxima, and here at 3 pi by 2 it is local minima. Now this function, because the rule says that first we have to set f dash x equal to 0, and then we have to solve this and find some values of x. Here n is integer, so n is integer. Now I put n as 0, so n as 0, then I get x as pi by 2. If I take n as 1, I get x as 3 pi by 2. If I take n as 2, then I get x as 5 pi by 2. If I take n as minus 1, then this is minus pi by 2. X equals minus pi by 2. Then the rule says that we have to find the double differentiation of the function and then check for which value it is greater than 0 and for which value it is less than 0. So the double differentiation of fx is minus sin x. Now I put one value. Suppose if I put x is pi by 2. So if I put x is pi by 2, sin pi by 2 is, so f dash pi by 2 is minus 1, because sin pi by 2 is minus 1. So it means at x equal to pi by 2, this is negative, means it is maximum value. Now check it out, this is pi by 2 and here you are getting the maximum value 1. Now I take one more example, f dash. Suppose if I find for 3 pi by 2, so 3 pi by 2 means this is the value of minus sine 3 pi by 2. Now what is the value of sine 3 pi by 2? Sine 3 pi by 2 is actually, if you convert this in the degrees, so this is sine 270, that is sine 180 plus 90, and sine 180 plus 90 means it is sine 90, but since it is in the third quadrant, therefore this will be negative, so it is minus 1. So this value is minus 1 and the minus of minus 1 will be plus 1. So f double x is positive, therefore this is minima. So this is minima and this is maxima. And if you are interested to find out the value of maximum, then you put sin pi by 2. So this sin pi by 2 is 1, so 1 is the maximum value. If I make this loop goes forever, then you will have the many peaks, and at all those peaks it will have the maximum value of 1, and here it has many troughs where the maximum value of the function will be minus 1. So this is one simple example. Now let me clear the screen and then I'll take another example. Now here I have taken another question which goes like this: if y is ax minus b over x minus 1 x minus 4 has the turning point at p2 comma minus 1, find a and b and show that the y is maximum at p. So it means turning point means the point where the maxima, minima, where the increasing function, decreasing function. Turning point in mathematics are actually like that. This is turning point, means from here to here it is increasing function, and at this point, before it becomes a decreasing function, it takes a turn. So from here to here it is increasing function, and then from just after this point it becomes a decreasing function. So this point is called as turning point. Same way you can have also a turning point like this, where this is from here to here it is decreasing function, and then at this point just before it becomes increasing function there is a turning point, and this is the turning point where we find the differentiation 0. That is the point where the tangent at that particular point becomes 0. It means the saying that turning point is this, it means they are saying that dy by dx at p equals 0. So one condition we have found. Another condition is that since this point P or this point P, this lies on the curve, so you can say P lies on the curve. P lies on the curve y. So the coordinate of P, that is 2 minus 1, will satisfy the equation of this one. So it goes like minus 1 is 2x minus b, 2a minus b over, I have to put the value of x is 2. So 2 minus 1 is 1, this is 1, and 2 minus this is minus 2. So therefore you get 2a minus b equals just 2. This is your equation number 1. Then you find dy by dx, because we have to set the dy by dx as 0, and now this is in the form of, you can say, u by v rule. So here I find this dy by dx. So the denominator constant, so I keep this whole thing x minus 1, x minus 4 constant, and then I find differentiation of ax minus b. So differentiation of x is 1 and a between it is constant. So differentiation of ax will be a into 1, that is a, minus 0, that is a. So a minus, then I keep the ax minus b constant. So ax minus b constant, and then there I have to find differentiation of this x minus 1, x minus 4. So I can use method of UV rule, is product functions, to find. So here I just keep x minus 1 constant, and then differentiation of x minus 4 is 1 plus x minus 4 constant now, and differentiation of x minus 1 is x, this is x minus 4, and this is also 1, whole divided by denominator square. So x minus 1 and x minus 4 whole is square. Now since this value is 0, so I just put it 0, and then 0, this 0 into anything is 0, so this denominator also vanishes, and we have this part which is a times x minus 1 x minus 4, a times x minus 1 x minus 4 minus ax minus b, and then there you have to add this 2x minus 5, 2x minus 5. Now you try to solve this equation, try to find out how you can solve them. So what you see, 0 is a, this one is simply x square minus 5x plus 4 minus, this one is 2a x square minus 2bx minus 5ax plus 5b. Then I try to keep the similar terms together. So 0 equals, this is ax square and this is minus 2ax square. So ax square minus 2x square will be just minus ax square. So minus ax square. This is minus 5ax. A into minus 5ax is minus 5ax, and this is minus 9, this is plus 5x, these two cancel. Now we are left with this term, which is plus 2bx, and then we have to find the constant term, which is 4a here and minus 5b there. So this is plus 4a minus 5b. Now if you see that on this side you have quadratic expressions with the value like minus ax square plus 2bx plus 4a minus, means coefficient of x square is minus a, and the middle term, this coefficient of x is 2b, and the constant term is 4a minus 5b. On this side you find there is no x square. What does it mean? It means a is 0. There is no x terms either, means b is 0, and there is just a constant term which is 0. It means 5a minus 4b is 0. So on the basis of this comparison we have to find the value of a and b. So on the comparison of coefficients we can conclude that the 2b equal to 0, therefore b equal to 0. Now if b is equal to 0, so this becomes 2a equal to 2. Now a equal to 1. So we get the value of a as a is 1 and b as 0. Now if you put the value of a and b there, then your whole expression becomes y equals x over x minus 1 and x minus 4. So this is our original function. It becomes like this. So this is my function. Now I want some screen space, that's why I need to clear this one. So just give me okay, so the y is, so we have now our y equals x upon, this one I write as x square minus 5x plus 4. So again we have to find the dy by dx, and this is x square minus 5x plus 4 as it is, differentiation of x minus 1, and then x times it is 2x minus 5, and this is x square minus 5x plus 4 whole square. So if I set it at 0, then it will become 0 equal x square minus 5x plus 4 minus 2x square plus 5x. These two cancel. We are getting minus x square plus 4 equal to 0, means x equal to plus minus 2. Now we have to find the double differentiation of this one to check whether it is maximum or minimum. That is the tricky part, or you can say the previous part. So let me clear this part of the screen, then I will come back to you again. So here I write my dy by dx. This is my dy by dx. So what it is, you see that on the top you have minus x square, this one, and plus 4. So minus x square plus 4, and denominator you have x square minus 5x plus 4 whole square. Then I find d square y by dx square. D square y by dx square equals denominator, first I keep denominator as it is, so 5x plus 4 whole square, and differentiation of this is minus 2x. Then I write this part as it is, that is 4 minus x square, and then differentiation of this part, which will become 2 times x square minus 5x plus 4 times 2x minus 5 upon x square minus 5x plus 4 whole to the power 4. So this is the way you can find the value. Now we have the two values, that is plus 2 and the minus 2. So I find that x equal to 2. Let's see what I am getting. So 2 square, this is, now if you see this term x square minus 5x plus 4, you see directly this one, then this is just this much. Here you have to put the value of x is 2. So 2 minus 1 is 1, and the 2 minus 4 is minus 2. So this whole value is minus 2. So if this is squared, this will become 4. And this is minus 2 into 2, that is also 4. So this part now becomes 16 minus 4 minus, and this is 2 square 4, so this whole part just vanishes, this whole part, because x 4 minus 4 square where x is 2, so this part just vanishes, and then you have only 16 on the top, and bottom this is again same thing, that is minus 2 to the power 4 is 16, so this value 16 by 16, that is roughly 1, which is a positive number. It means at x equal to 2 it is minimum value. So this is at x equal to 2, it is minimum. Same way you can put the value of x as minus 2 and you can check whether it is maximum or minimum. So this is the way we try to solve the questions of the maxima and minima. In the next video I'll take some more examples just to clear my point of view or to clear the ideas of maxima and minima.